What's a super hexagon? Does it help us remember all the trigonometric formulas and identities? Yes, it does. Hey guys, welcome to the Simple Maths channel. Today we're going to look at a concept called a super hexagon. A super hexagon is a simple hexagon that looks like this. Normal, right? Let's first join all the vertices, which gives us 3 diagonals. We write the number 1 in the center. Now to know all of our formulas, we need to have all the function names to each of the 6 vertices. However, there is a certain way in which we need to write it. We have to start writing from this vertex, go around the hexagon in a clockwise motion, and stop at this vertex. Now let's see how we can write the 6 functions at the 6 vertices. We will only need to remember one formula, which we have already seen before. Tan is equal to sine by cos. We will start at this vertex and write tan, sine, and cos in the clockwise motion that was mentioned before. Now to fill in the remaining 3 vertices, we will write cot opposite to tan. We have to make sure that all the functions starting with c are on the right side of the hexagon. Now we will write cosec and sec in the same clockwise direction. All done. Now all you have to remember is how a super hexagon should be drawn. Now let's put the super hexagon to the test. Reading this hexagon in clockwise motion will reveal us some formulas. We now know that tan theta equals sine theta by cos theta. Now let's look at our next set of formulas. We know that sine theta gives us cos theta by cot theta. Now let's look at the next 3 functions in a clockwise direction. This tells us that cos theta equals cot theta by cos sec theta. And the next 3 functions tell us that cot theta equals cos sec theta by sec theta. Next is cos sec theta equals sec theta by tan theta. And finally, sec theta equals tan theta by sine theta. How about anti-clockwise? Anti-clockwise will pretty much give you the same answers, so you will not have to worry about forgetting which way to go. Tan theta equals sec theta by cos sec theta. Sine theta equals tan theta by sec theta. And cos theta equals sine theta by tan theta. 1 hexagon and 12 formulas, but there's still more to go. Let's check it out. Let's first redraw our super hexagon. In our previous set of formulas, we didn't actually use that one that was placed in the center. Now let's see why it's placed like this. If we multiply the functions that are opposite to each other, we get 1. Sine theta times cosec theta equals 1. This multiplied by this also gives us 1. Cos theta times sec theta equals 1. Tan theta times cot theta equals 1. From this, we know that when functions that are diagonally opposite from each other are multiplied, they equal 1. But there's still more we can learn from the super hexagon. Let's rewrite our super hexagon once more. We know that all these functions are reciprocals of each other. Look at this arrow for instance. This arrow indicates that sine theta equals 1 by cosec theta. This arrow tells us that cos theta equals 1 by sec theta. And this arrow tells us that cot theta equals 1 by tan theta. There's still more. Do you remember complementary angles? It is said that 2 angles are complementary if their sums equal 90 degrees. We also know that the trigonometric functions have a special relation with complementary angles. For instance, let's look at this arrow. It tells us that sine theta equals cos 90 degrees minus theta. This tells us that a sine of an angle is equal to the cosine of its complementary angle. Similarly, this line tells us that tan theta equals cot 90 degrees minus theta. And this arrow tells us that sec theta equals cosec 90 degrees minus theta. Let's now look at a final set of formulas. Let's again redraw our super hexagon. Look at this figure closely. We can observe that there are 6 triangles formed inside this hexagon. Let's focus on 3. This one, and this one. Here, we go clockwise within each of the triangles, starting with the top left position, like this: sine, cos, and 1. This gives us one very important identity. This squared plus this squared equals this squared. This means that sine squared theta plus cos squared theta equals 1. Now let's go clockwise in this triangle. 1 plus cot squared theta equals cosec squared theta. Let's go clockwise in this triangle as well. Tan squared theta plus 1 equals sec squared theta. Going anti-clockwise will give us a minus sign before the second term. 1 minus cos squared theta equals sine squared theta. Cosec squared theta minus cot squared theta equals 1. Sec squared theta minus 1 equals tan squared theta. Finally, we're done. Now we know why they call it a super hexagon. One hexagon helped us with so many formulas in trigonometry. If you found this video helpful, make sure to like and subscribe for more.